Within the next 15 years, many of you are very likely to be faced with a question: do you want to have your genome sequenced? And when that question comes, you're going to have to weigh up the benefits and the harms and make a decision that is right for you. You may be asked this question because you are a patient with a rare disease. You may be asked this question because you're the relative of a patient with cancer. You may be asked this question because you are being invited to be a participant in genomics research. And you may be considering this question because you're considering it as a consumer. Whatever the context, when that question comes, you are going to need to weigh up the benefits and the harms and make a decision that is right for you and your family. Today, what I'm going to be talking to you about is genomics and genome sequencing. But what I hope to convince you of is actually not the importance of genomics itself, but the importance of psychology as applied to genomics. Psychology is the scientific study of the mind and behavior, and it is crucial to the field of genomics because the way that you think, the way that you act, and the way that you feel in response to getting personal genomic information about yourself is going to be central to our understanding of the value or utility of genome sequencing. So first of all, what is your genome? Your genome is your complete set of DNA, including all 20,000 of your genes. It's packaged up into this familiar double helix shape, and you have a copy of your genome inside almost all of the trillions of cells that make up your human body. Your genome acts like a kind of instruction manual for your body, and it's made out of these 4 chemical units or letters called A, T, C, and G. There are about 3 billion of these letters in your genome, and the order of these letters is called your genome sequence. About 99.9% of the letters in your genome are identical to every single other person's on this planet. Now, it sounds really small, but that 0.1% that differs between you and other people is actually really important. If you think about it, 0.1% of 3 billion is actually still 3 million, and those 3 million DNA variants influence all sorts of things, like what you look like, your disease risks, and how your body responds to medications. Genome sequencing is a technology that allows scientists to read the order of the letters in your genome. To do this, a blood or saliva sample is taken. The sample is sent to a laboratory where the DNA is extracted. The DNA is then processed by a DNA sequencing machine. And at the end of this process, a list of 3 billion letters is produced, including that 3 million that differs between you and other people. Now, this list of letters, that raw data, is potentially incredibly powerful, but actually it tells you precisely nothing until it's been interpreted. To interpret your data, scientists have to go through those 3 million variants in your genome to find the ones that might be important for your health. And they do this by comparing the variants in your genome with those in large databases that are compiled of the variants from lots of other people's genomes. Just 15 years ago, only 1 human genome on the planet had been sequenced. And to sequence that first human genome, involved dozens of laboratories like this one across the world. It cost $3 billion US, and it took 13 years to complete. Fast forward to today, and today you can sequence 1 human genome, a whole human genome, on a single machine like this one in less than 48 hours for less than $1,000 per genome. Today, hundreds of thousands of people have had their genome sequenced with cancer, with rare disease, and for clinical and for research purposes. So fast forward another 15 years, and it's been projected based on current trends that by the year 2033, tens of millions of people will have had their genome sequenced, again, for research or clinical purposes or for both. The speed at which genome sequencing technology is developing is astounding, and yet you will hear people refer to genomics and genome sequencing as hype. It is not hype, it is hope. If you look at how far we've come in the last 15 years, it seems virtually impossible to think anything other than that within the next 15 years we are going to be using genome sequencing to help us in the diagnosis and treatment of all sorts of conditions across our healthcare. The question is no longer whether this is going to happen, but how. How we are going to deliver this technology within our existing healthcare system is a very serious and real and large challenge that many people are working very hard to address right now. And in addition to those practical challenges, you will often hear people say that the genome sequencing raises many ethical questions for us as a society. Now, some of these ethical questions are about the potential impact that the results are going to have on individuals. How are people going to cope with the results, and will they actually act positively on them? But if you think about these questions about the impact of personal results on individuals, they're not just questions of ethics and society, they're questions of psychology. They are psychological questions. How will people understand the results that they receive? How will this impact their behavior? How will it make them feel? How will they get the support that they need afterwards? And what support do they need? All of these are questions that the science of psychology can and should be used to address. Over the years, I've thought a lot about genetics and psychology, and the reason for this is that my mum has bipolar disorder. She was diagnosed with bipolar disorder not long after this photo of us was taken. She is a beautiful person, and I have had many lovely times with my mum. And there have also been many much harder times as well. I have visited her in psychiatric hospital over and over again, and I have asked myself, ever since I was a very small child, why did she end up developing bipolar disorder? What made her the way she is? Why did she develop bipolar disorder when other people didn't? And it always felt like there was some kind of genetic vulnerability in her that, together with difficult things that she experienced in her life, had somehow triggered something inside her that just didn't seem to be there in other people. You know, sometimes we talk about what's more important. Is it nature or nurture? Is it genes or environments? And of course, it's both. It's genes and environments. And we can even go beyond this to say it's genes via environments. Understanding this has led me to ask, if my mum had known that she was genetically predisposed to developing bipolar disorder, and if we had known what those specific gene variants were, could something different have been done to prevent or reduce the severity of her symptoms? Could she have been given different or more psychosocial support to help her deal with early stresses in her life? Could she have been spared the trial and error approach to psychiatric medications that sometimes don't work, sometimes lead to unpleasant side effects, and often both? And would she have wanted to know if she was at genetic risk? Would this have helped her or hurt her? Would it have made her feel empowered or more stigmatized? And would I have wanted to know if I had inherited those same gene variants from her? For us, all of these were hypothetical questions only, because the complex interacting effects of our genes and environments and our life experiences on our mental health are only just beginning to be understood. But our understanding of the role of genomics in our physical health is more advanced. Today, we already use genomic information about cancer to identify some people who are at increased genetic risk of developing cancer in the future, and multi-gene risk scores for heart disease are really starting to show promise now. Very soon, we may be able to use genomic information to identify people in the general population who are at very increased risk of developing cancer or heart disease, so that risk-reducing strategies can be made available to them, and they can take action to reduce their risk long before they or their relatives ever start showing symptoms or developing advanced stage disease. So the hope is that genomic information is going to empower people to take action and reduce their disease risks. The concerns include that we're going to cause psychological harm. Instead of empowering people, are we actually just going to make people feel stressed and anxious by high-risk results? And are low-risk results going to falsely reassure people and make them think that they can eat and drink and smoke whatever and however much they want? How can we know the answers to these questions? Well, we can do the research. Let me give you just one example. While I was working at the Icahn School of Medicine at Mount Sinai on the Upper East Side of Manhattan in New York, my colleagues and I conducted the HealthSeek study, in which we returned personal results from genome sequencing to 35 generally healthy individuals. As a psychologist on the team, I worked closely alongside my colleagues who included bioinformaticians, computational biologists, clinical geneticists and genetic counselors. And together we worked as a team to design the research right from the start, so that in addition to developing the genome sequencing pipelines, we also developed the questionnaires and the interviews, so that we could interview patients, participants, before they got their results, and then immediately afterwards, and 1 week afterwards, and 6 months afterwards. And what did we find? Did low-risk results lead to false reassurance? No, we saw no evidence of this. Did high-risk results from genetic risk scores for type 2 diabetes and heart disease motivate people to change their lifestyles? No, we saw no evidence of this either. Did high-risk results prompt other types of behaviors? Actually, yes, quite a few people did discuss their results with their clinicians, and they had various tests and procedures based on their results. And did high-risk results cause anyone distress? In most cases, no. But in one case, yes, and I'd like to tell you a bit more about that. What this graph is showing you is participants' distress levels 1 week after they got their personal genomic results, so the 1-week follow-up. We measured distress using an adapted version of the micro, which is a widely used measure of distress relating specifically to personal genomic results. And each of the dots is a participant, and what you're seeing is that most participants scored very low or 0 distress, but some of them scored a little bit higher, and one stood out in particular, highlighted here in the red dot. This participant was a young man in his 20s, and through the project, he'd been told that he had a rare variant in his DNA that appeared to be associated with very increased risk of sudden cardiac death. When we talked to him in that 6-month interview, he told us that he had indeed been very distressed when he'd first got this result, as you can imagine. He'd had an appointment with a cardiologist, he had had various tests and procedures, and on the basis of that consultation and the test results, he had gradually become reassured, and over the months, his distress levels did come down so that by the 6-month follow-up, they were much lower. However, what also happened for this participant is that he was also informed in that first result session that he had a very significantly increased genetic risk of Alzheimer's disease as well. When we talked to him in that 6-month follow-up, he told us that he hadn't even heard the Alzheimer's result in the result session. He'd been so focused on the sudden cardiac death result. But over the months, as he dealt with the cardiac result, his attention had turned to the Alzheimer's result. And in many ways, 6 months later, he was now thinking more about the Alzheimer's result than the cardiac result. But we know, because we'd measured depression before and after he got his results, that he had not become clinically depressed. And we also know, because of our measures and our questionnaires and our interviews, that he did not regret learning this information about himself. So this was one of the very first early studies to start exploring the impact of genome sequencing on individuals. But what I hope it shows you is the importance of doing the research not only to develop the technology, but also to understand what the impact of the technology is on individuals. Within the next 15 years, many of you are going to be faced with a question. Do you want to have your genome sequenced? And when that question comes, you will have to weigh up the benefits and the harms and make a decision that is right for you. This is why we need psychology as applied to genomics. It is only by doing this kind of research that we're truly going to come to understand what the benefits and the harms and the outcomes are for individuals and therefore for society. And by doing this kind of research, we will also come to understand how we can maximize the benefits and minimize the harms as we start to deliver this technology within our healthcare systems. My personal hope is that we will also soon be ready to start translating psychiatric genomics into personal information for individuals, so that we can start to explore whether this is going to enable us to do a better job of helping people at risk of mental health issues, like my mum. Thank you.